Lesson 8, Voltaic cells. So an electromotive force is a spontaneous redox reaction. So it just occurs. It's a redox reaction that just happens that is used to generate an electric current. Because remember, electrons are really what makes up a current or electricity. So because electrons are being lost and gained in a redox reaction, there is a current. Okay? So electromotive force stands for electron motion. So here's an example. Here's two half cells, which is a oxidation coupled with a reduction. So zinc being oxidized, losing electrons to zinc plus 2. Copper ions gaining electrons to become copper solid. So these two half cells would generate a current between them because zinc is losing the electrons and copper is gaining the electrons. And since the electrons are moving, that's a charge. So electrons flow through an external circuit when we talk about voltaic cells. So the first part of a voltaic cell is called a half cell. And half cells are strips of metal in solutions of the metal ion. So here's an example. This beaker is a half cell. The metal is zinc and the solution has zinc ions in it. Here's the other half cell. The metal is copper and the solution has copper ions in it. The electrode potential is the charge separation between the metal and its ions in solution. So a voltaic cell is when we connect the two half cells together. So here's a wire connecting them, and over this wire flows an electrode potential or a charge. The anode is the electron where oxidation occurs. So because zinc is losing its electrons to become zinc plus 2, it's losing electrons, so that's the anode because it's being oxidized. And the cathode is where the reduction occurs. So because copper ions are gaining electrons to become copper, this is the cathode where reduction occurs. And you can remember this by the acronym RED-CAT. Reduction is at the cathode, which means that the anode is oxidation. Now, in order to generate a current, you have to complete the circuit. So this wire is pivotal because it connects the half cells together. This completes the circuit and allows the current to flow. So, again, completing the circuit requires an electric wire that's connecting the metal electrodes. And electrons always flow from the anode, because anode is oxidation, it's losing the electrons, to the cathode. Cathode is reduction, so that's gaining the electrons. Now, this funny U shape is called a salt bridge. So in order to balance out the charge, because this is continuously losing electrons, which means it's becoming more and more positive. And this is continually gaining electrons, so it's becoming more and more negative. So eventually it would burn itself out. So what happens is you put a salt bridge in, and the salt bridge allows the charges to balance. So this side that's becoming more and more positive because it's losing electrons, the salt bridge allows positive ions from here to come over the salt bridge to balance out, more negative ions to come over the salt bridge to balance out that positive charge that's building up. And over here where all the electrons are going, the reduction, it's gaining electrons, becoming more and more negative, the salt bridge allows positive ions to come over to the more negative side. So you usually put something that's non-reactive in your salt bridge, such as sodium nitrate or potassium nitrate. So the negative ions are going to come over this way, the nitrate ions, in order to replace those electrons that are being lost. And if this was KNO3 in our salt bridge, the potassium would be coming this way to the cathode in order to replace that positive charge, because remember, it's building up a lot of negatives because it's pulling all those electrons in. So again, electrons flow from the anode, so we make it a negative side on the anode, to the cathode. So we make that a positive sign on the cathode, because the negative is losing the negative electrons and they're going towards the positive cathode. So when you have different half cells, the voltage or the current that goes across that wire will be determined by the difference in reducing strength of the two metals. So for this, you need to know where they are in the activity.
When a strip of zinc metal is immersed in an aqueous copper 2 sulfate solution, Electrons transferred from zinc to the copper-2 ion. Copper metal deposits on the zinc strip and collects at the bottom of the flat. Zinc atoms are oxidized to zinc-2 ions, which enter the solution. This spontaneous oxidation-reduction reaction is summarized in the chemical equation shown. The spontaneous copper-zinc oxidation-reduction reaction can be made to useful electrical work by incorporating it in a Voltaic cell. The zinc electrode is immersed in a solution of zinc sulfate. The copper electrode is immersed in a solution of copper-2 sulfate. No current flows through the light bulb because the electrical circuit is not complete. To complete the electrical circuit, we add a tubular bridge filled with aqueous sodium sulfate solution with a porous plug on each end. We now have a complete circuit and current flows. When we replace the light bulb with a voltmeter, we find that the cell has a potential or voltage of 1.1 volts. The copper electrode is the positive electrode, and the zinc electrode is the negative electrode. As the cell reaction proceeds, zinc atoms of the zinc electrode lose electrons and move into the solution as zinc ions. At the same time, copper-2 ions acquire electrons at the copper electrode and form copper metal. The reaction in the left-hand compartment is oxidation of zinc. The electrode which oxidation occurs is called the anode. The reaction in the right-hand compartment is reduction of copper. The electrode at which reduction occurs is called the cathode. Electrons flow from the anode, the cathode, through the external circuit. To maintain electrical neutrality in the two cell compartments, ions must move through the salt bridge. Remember that in a Voltaic cell, the anode at which oxidation occurs is the negative electrode. The cathode at which reduction occurs is the positive electrode. Electrons flow through the external circuit from anode to cathode.